Hello, it's it's now 4 past the time that we had scheduled 1:30. That's 1:34, and I'll go ahead and start the presentation because this is recorded, so you can watch it whenever you have time. But basically, what we are going to do is just learn how to perform data wrangling with dplyr. And last week we talked about, or I walk you through our studio, how to set it up, and then how to create project folders. Today, we are going to take it from there. So let me go ahead and share my screen. Okay, I'm now sharing my screen. And we are here in my project folder. So let me open it up a little bit. So here, we are in R underscore tutorials. And this is my project. This R tutorial folder, or this is like a GitHub repo, and you will get the code on GitHub. I will add the link to the video when we are done. So I will walk you through what I do daily at work, how I clean my data, how I imported the data. I import data into R Studio, how I clean it, and I'll show you different functions from dplyr, tidyr, string r, maybe forcats, and use them to wrangle data. So let's get it started. First thing we will do is create a Quarto document. I mentioned last time Quarto is the modern, or is the next generation of R Markdown, and the POSIT, or the former R Studio company, will not will stop adding new features to R Markdown, and instead they are building and making Quattro like more user friendly. So we go here, our title. We are going to do some data wrangling. So let me find my title here. And then just drop it there. You can add your title here, or you can create a document and then later on add your title. You can also add your name. And we are using R, so we will leave the engine as need R. If we were using Python, we could have selected Jupyter, or we can use need R and then use reticulate package to combine or to use both R and Python interchangeably. Here, the default document format is the HTML, and now we'll leave it like that. Now we are going to create the document. And this is the document. There are a lot of other options that we can add here, but that's not important, because what is important to us is just doing the data wrangling. Now, when you create your document, it will come with some example of how the document is structured, but I will go ahead and delete everything because we will start from the scratch. What I will do here is I will first write the outline of what we are going to do. So the first thing we are, of course, here we are doing the data cleaning and transformation. So let's say data cleaning and transformation. And then under that, so we will load the packages that we will work with or libraries. And then after that, we will load the data. So import the data set. Might be using two data sets. And then after that, we will select columns of interest. After that, we will filter the data. That is, we will remove unwanted rows, remove or delete rows. After that, we will summarize the data. Let's say grouping and summarization. Yeah, if there is something, then we will add it on, but these are the steps that we will take. So usually or normally when I'm using R, what I do, I just, okay, so to add code chunk, you can come up here or you can do control, option command on Mac, or it's gonna be control alt on PC and I. Or the good thing about Quattro is here using the visual editor, I can just click the forward slash and it will give me the options. I'm working with R, so I'll choose R code chunk. Now we need to save our document before we start working, because if something happens to our computer, like our session crashes, then we may lose this information. So let's go ahead and save it. So I'll go to File and Saved As. We will save it in this data wrangling folder and I'll call it just code. And now we are ready. So some other thing that I usually add, like I suppressed warnings. Good thing about Quattro is you do the pound and the vertical line and then add a space and then type whatever the function of the option is. Here we are setting warning and message to false. There are other things that you could do. For example, we can say echo and then we set it equal to true or false, but I'm not going to do that. The other thing I do is I just label it as libraries. And normally I load just tidyverse to load all the tidyverse packages or meta packages. I'll have to control. So another thing I do, control command return key to run this chunk here, or you could display the button here. But it's faster. It is faster to just do command or control return if you are on PC. So we have now loaded our data. No, not our data, our libraries, which is they are just together in tidyverse. The next thing we are going to do is now import the data. Again, I'm using the shortcut /. If I'm on the source tab, like here, I won't be able to use the /. So // only works when I'm in the visual editor. Here I could do option command on Mac and enter that, or if you are on a PC, you do Control Alt I to enter. But I like to be in the visual editor. Now let's say import data. And there are two data sets here that I would like to use to demonstrate what I'm going to show here. The first one is the hospital general information from CMS website. This is the data set containing all the information about US hospitals with their star ratings or ranked by star rating from 1 or not applicable, not available, and then 0 to 5, or 1 to 5, actually 1 to 5. And then there are other measures. For example, there is hospital acquired conditions, which is called HEC reduction, and then the readmissions reduction. Those are also in there. I will use this data set just to demonstrate how to select how to select or remove columns that you don't want using select helpers. After that, we will switch over to the South Sudan 2008 census data that I always use to do further demonstration of functions. So we can just call this hospital to add the, here you can do the equal sign, but in R, it's agreed that we use this assignment, the lower than and then dash or minus as the assignment operator, but equal sign can do it. And I'm going to use the room package. So if you don't want to if you don't want to load a library like I have done here with Tidyverse, you can call the name of that package and then do double columns and then the name or the function that you're going to use from there. For room package, it's just the room that we use. And as you can see here, these are the options, like call names is set to true by default, call style, call underscore types, etc. So we use the quotations and then here do this one. So this is where I am, but I'm already seeing the data that I want here. Now, if I do command return, we're going to get a lot of messages here. And it is telling us that this data has 5,320 rows and or observations and 29 columns or variables. And it is saying column is specification and delimiter, comma separated. So we can suppress this here. It says use a spec to retrieve the full column specification for this data set. Another thing is saying is specify the column types or set show underscore call underscore types equal to false to suppress, to quiet this message that we are seeing or messages. So that's what I'm going to do. I will come back inside here, say show, we set it equal to false. I always like to clean it up a little bit. So let me I'll come to a second line. So in R, you can do it this way, or you can do it the way it was like this. So it's allowed that you can do this thing here, like here. So I'll come to the second line so that we can clearly see both of these. Okay, so let's see. Okay, now it's well lined up. So we are reading in the data. anywhere above or in the middle of this code chunk, I can, or lines, I can click control command return, and that will run it. Now we are not seeing the messages, but our data is here in the environment. This is the data we have. So we see a lot of columns. One thing we need to pay attention to is the commonality in the column names. So here we see like footnote. In this other column, we see comparison. So let me go back. Yeah, so we see footnote, we see comparison. Those are common across the column we have. Okay, I see here something is wrong with the way I name my code. So I'll close it. So let me save it first and then I'll close it so that I can fix that error there in the name. Oh, no, so here what I can do, I can click here and then I will go here. Okay, let me pull it further away from there. And here I can rename it. So I will remove that QM, it was a duplication. Okay, now that's what we want. And then I'll go back here. So looking at the data set, we see these column names are like phrases with spaces in between. It's not easy to work with column names like that. So what I will do, you can also move the tabs around by just dragging, drop. So what I will do here, I will use a package called janitor to clean, or actually let me leave it here, then I'll go to the next, or I can do it here. So let's say we want to clean column names. I'll type janitor and it is just clean name, and then command return, and that will do it. Now the spaces have been replaced with the underscores and all the names have been changed to lower cases. The reason I didn't specify the type here is because the snake case is the default option, but you can do capitalization and other options that you can choose there. So that's it. But looking at the columns, we don't care about the facility ID. We care about the facility name. We don't care about the address. We maybe care about the city, but not now. I will just select the state. Don't care about the zip code. We don't care about county name or county. We don't need their phone number. We may need hospital type. We may need hospital ownership. We may need to know if this is like a emergency services or not. We may not care about this meets criteria because this is too long. I will remove it. And so on. So the way we can look at the names, we can glimpse the names, so we can add, sorry, I press the wrong key, so it's option, it's shift. Okay, to add a pipe is shift command M, and then we can glimpse. So this is a function from dplyr that will let us look at the structure of this, look at the columns and their types. So these are the columns we have. So for example, we have already said that there are about 5,320 observations or rows, 29 columns or variables. So Facility ID is a doubled or numeric, and facility name, of course, is a character, and so on. So these are the names, and so we are going to pull out. But good thing here, there's no right or wrong way when you are cleaning your data. The right way is the most efficient way to save time and to reduce amount of work that you're, yeah, actually the same thing, to save time and to make your work more efficient. So the fact that we have these names here with comparison in them and footnote, we know these columns with footnotes are not important. So we can easily group them together and then remove those. And then comparison names, those we will need them, so we can leave them there. So columns that we will remove, any column that contains or ends in footnote, we will remove. And then we will remove the location. We will remove facility ID. We will remove phone number and county name, city name, address, and so on. So now let's do it. This here is going to bring us to, so I will remove the glimpse function here. So this will bring us to the selecting columns of interest. Again, Option Command I to get a code chunk. And so it's much easier for us to remove columns than to select columns, because there are fewer columns that we don't want compared to the columns we are interested in. So there are select helpers that we can use to work with columns. You use the select function from dplyr, but there are selection helpers in dplyr and also tidyr that you can use. Contains, it starts with, ends with. These are the three that we will use. The rest we will not use. There is one off, there is matches, and so on. So first thing we will do, we can select, so we can select columns, selecting columns using position or index. So let's say maybe hospital, maybe table. And then now we call the hospital data set. And we add our pipe. And now we want to select. So we can select this here based on position. What I mean is, we know facility ID is not a position 1. Address is 2. City is 4. And so on. So we could come here and say, and to remove, you just put a minus before it. So we can say, and since there are a lot of them, we can say, okay, we want to remove, delete column 1, we need to delete column 3, 4, and etc. And then we run this here. And when we see it, we see that we have gotten rid of that the facility ID. We have gotten rid of the the address. We can also get rid of this zip code and so on, but I just wanted to show that you can do this to remove columns. Now I'll comment it out. To comment it out, it's a Shift Command C or Shift Control C on PC. And then now we will use select helpers. Or let me show again, we could have said facility ID. Yeah, we can also use the grouping and use that C address. And let me see what the other thing was. City. And then city. Now we run this one, command return key, and it will be the same thing. So either we use the indices, the position, or we use the column names that will give us the same thing. Now the thing you can do, you can come down to the next line. So make sure it's clear, people can see it. So let me add another code chunk so that I don't overcrowd that code chunk there. And let me just say, I would call it hospital, maybe just short, and then say hospital, add my pipe. Now we are selecting columns, but we will select columns that we don't need. So here we will do it just the way we have done it up there by using column names. So we will say, okay, we don't need facility ID. We don't need the address. We don't need city. We don't need, here I'm separating them using comma. We don't need zip code. And good thing is just do an auto completion, which save me time. Now this is where we are going to say, okay, we can say contains, or we can say ends with. We have mentioned earlier that those columns that end in footnote, we don't need them. We don't need location here. We also don't need this long column here where we are saying it is meeting criteria for promoting interoperability. So I will use those three last letters. I can say ends in underscore RS, or I can use all those four. So say here, I'll say, or I can say contains, just to show that it doesn't matter which function I choose, it will do the same thing. So I would say EH underscore RS. Now let's run this and see what will happen. So I'm getting an error. And let's see what the error message is saying. The problem while evaluating contains this year caused by error in contains could not find the function contains. I didn't say constraint, so it's a spelling error. I say constraints. Okay, good. But I forgot to add the minus to remove it. So now let's run it. We come here. We see that we have cut it down to 15 columns. Columns here. So we don't need count, so we will remove that. We don't need the phone number. And yeah, we need all these. So there are two more columns that we want to remove. And we can say, I can say it starts with this year semi time. Let's say phone. Now let's see if it's gonna remove it. We'll come back here. Now we are down to this 14 columns. So this here has column as county in it. We can say contains county, or we can say start with county, and so on. So let's say it starts with, or let me just use the contains county. When we come here, now we are down to 14. I didn't do it, so what did I do wrong? I didn't put a minus to remove it, so that's why. Now we remove it. We come back here, we have 13 columns. So basically, this is how you work with columns, remove columns, using position like index, or using just removing them by names, column names, or using select helpers like ends with, contains, starts with, etc. And you can add comments in the chat so that I can answer your questions if you have any questions. Now we are done with this data set. The other data set that I'm going to load is the South Sudan 2008 census data. So I would say here, import data set, then option command I, and then I just call it census, or let me say raw and then I'll still use, or I'm not going to use broom. I will just use read R, so that I say read underscore CSV, but I like broom because it's faster, although my data is not that large. And then quotations, now we go in there, but our data set is already here. So let's run it and see. We will get messages like we saw earlier, so we need to suppress these messages. But again, I will break this one to the second line and drag this one to the second line as well. Do this one, I'll hide this outlined. And now add a comma at the end, come down, show, set it to false. Now we come down to raw. This is the data set that we have. There are a lot of columns that we don't need. This column here, region, we don't need. We need the region name because these are the states. We don't need this here. Don't need the variable. We need the variable name because this here contains the gender and the total rows. We don't need age. We need age name because those are age categories. And then we need this last column, which is the population column. So I had forgotten to put on my microphone. So I don't know if you have been hearing me or not, but I'll keep going. So now let's go here. So this is the data. There are other options. If we press here, we can see that we can add column names, columns type, column underscore, select the columns that we would like to keep. So you may decide to just say, okay, give me these columns and so on. That's not what we are going to do. So the other thing we are going to do, like we did earlier, is to clean column names. replaces spaces with underscores, and convert everything to lower cases by using janitor or clean names from janitor package. Okay, and then now we will come and select the columns of interest. I'll call it census. Option to get the assignment operator, so row and the pipe. Now we are selecting the columns we need will be the region underscore name, but we will rename it. So let me come down here. We will call it state. So this is how you rename columns or you can do it like this. There are two additional ways you can name columns, but this is one way. And then we need variable name. We will call it gender, the variable name. Age name, we will call it age category. Population, we will call it population. I think it is X 200. So let's run it and see what census is. Now we are down to only 4 columns. Those are the real important columns that we are interested in. So as we can see here, this column here, gender, as population, comma, total, and then number in parentheses. We need to clean it up. I would like to only keep rows with either male or female. We will also clean up the age category. And to do that, we will come here. Oops, sorry, I pressed the wrong button. So it's Shift Command M. So the first function we can use, we can separate those. So we can split column values using the separate function. And you put in the column that you want to separate as gender. We want to separate it into, so you say into, and then now we can use the C function. We can separate it by using the comma or the spaces. So let's say we separate it by, it's better to separate it by using spaces. The reason I'm saying that is because I see male in the center here. If we do comma, then this number in parentheses is still going to be attached to male and female. So it's better to separate it using, that means we need 3 columns here. So I would just say A. The middle part is what we are interested in. So I will call that gender. I will retain the name gender. And the last part, I will just call it B because we will delete those. We are not interested in those. Now, if we leave it like this, let's leave it like this without specifying how we want to separate them and run it and see. So here we are getting this message warning here, but let's go and see it. So now this has been separated. So by default, it is separated using spaces. And this is exactly what I wanted. So I will delete A and B because I don't need those. But here it is good to be explicit. So I'm going to say set equal space. Add that. And now we are not getting that warning message. Now I keep doing that. Now let's add a pipe. And adding pipe, we can select. So the way we remove columns we don't want is to use a select function. So we will use C and B, we don't need those. A and B, we don't need those columns. They were just placeholders. And now we don't need columns with totals in them. But before we go there, what I will do, or actually now the next thing to do is just to filter columns. So we will come down. This is the data we have now, this data here. So we will come down here where we are saying filtering, and we will add a code chunk option, command I. Still the same census, we will override it and then keep it the same. And we will use the filter function from dplyr. It's gender, but we don't want gender. We don't need the total columns. These are the total populations, like the state so total population. So we don't need that. In the age category, we also don't need the total rows. So we can do this here. And because I'm getting an error, and it is said error in filter. We detected a name input. This usually means that you have used equal sign instead of. So in R or programming, you do double equal signs to show that it is exactly, or to show equality. And then now we have filtered out these, but that is not what I wanted. Now we want to negate. We can negate by putting an exclamation point before the column name like this. And that got us nothing. So this is what I will do. We don't want the equal, but we want to negate it. So we put exclamation point and then the equal sign to say we don't want those rows, give us the opposite. Now let me see why I'm not getting what I want. So let me undo it. And this is why it's important not to override the data set. So let me rename it maybe 2 and come back up here. Now let's see. So this is here. Gender is showing this here. And so it's total. Now let's come back and try again. Let's say not equal total and see why. Okay, now that has worked. So now we have removed those, but there are still total rows under the age category. So we will also remove those. We don't want them. So we can say and, or we can use comma, or we can say and age category not for. We have removed total rows from there. Now let's say we want to say equaled and equaled to get only rows that contain all the totals, but we don't need these. So can we get rid of these? So what about if I say exclamation point and put this condition in parentheses and now run it and see what we get? And it did it for one side. So it didn't do it. And let me use the or. Okay, so it has to be or. This is if gender is equal to total or if age category is equal to total. But if we just say and, then that is not going to work because both have to be true, which is not uh, what we want. Let me comment this out because I want to try something else. I want to try like this to verify, to make sure that what we are getting is actually correct. So say gender is not equal to age category not equal. Here we have 280. Let's see what we will get when we do that. We still have 280. So this condition up here is correct. Okay. So this is how you use the filter to remove. In our case here, using these conditions. And then looking at our data, the remaining thing is we want to modify age categories because it's gone from 0 to 4. I would like to go from 0, maybe 0 to 19, or actually 0 to 9, no, 0 to 14, and 15 to 24, or 20, 29, and so on. So to do that, we will say we will use case when. So we will use the mutate function. The mutate function, it's age category that we would like to modify. Here we can use equal sign, and then we will use case when. Case underscore when. We can be explicit or we can say detect. So let's say str from string or detect. And to do that, let's see, these are numbers. So what we can do is come down here and say, okay, from our census 2 data, we can call the column by using the $sign. That's one way to call the column. And then we want unique values of the age category. These are the unique values. And I have said earlier that I would like to go from 0 to 14, make that as one category. So I'll copy this. And then I'll come back up. And I'll say detect. And then I'll use the vertical line to say or. So I'll say or. And so when I'm telling R to detect this category or that category or this category, and then name them as 0 to 14. Here I'm making a mistake. I'm forgetting to add the column that I would like to use, a column that contains these values. Let me see if I can come to the second line. Okay. Now I will do the same thing. I'll say str underscore detect age category, and then I'll come down. I want 15, from 15 to 29. Here it's me deciding what groups or which categories to lump together. So you decide there's no right or wrong. Another thing that I have done, I need to remove all these quotations because that is going to throw an error. Yeah. They have to be on the outer side. And remove this. That. Okay. Or this. And then we will call that 15 to 29. Then add another line str underscore detect age category. And now we are going from 30 maybe to 49. My objective here is just to show how to use the case underscore when. And then we need to be careful. So this is 32 through 49. And the slightest mistake will throw an error. And it would be hard to detect where that error is originating from. I'm going to do 50 to 64. We'll call this here 50 to 64. And there is only one category left. So we will say true. If it is true, set it equal 65. I can say yes, 65 and above or 65 plus. Now let's run it and see. If we don't get an error, then that means we did it correctly. And we come here and we see that these here, the categories we have created have been implemented. Upper Nile. Okay. Those have been implemented. So that's how you use the case underscore when. Thank you for joining us and for loving what we are doing. We appreciate it. And then, so looking at our data, I have talked about selecting columns, separating columns, and now using case underscore went to recategorize or regroup column values, and we use filter. I want to go back to separate because this column here, let me go to the raw data. This column here, we can use the separate function, but that's not the only way we can clean it up. So I will show you another way that we can clean up this column. So I'll come back here. I'll come back here and I will comment out this section here so that I can override it. And instead of doing it like that, I'll come at the bottom. No, I didn't mean to delete it because I want to keep it in there because I will be sharing this on LinkedIn, on GitHub, and then I would like you to be able to see what I did when you are coding along. I will use mutate, and I will use some functions from str or string r. So the column we are working with is the gender column. I will use str remove all. It's the gender column that we are working with. And I'll come down here. Let me open this up. I'll come down here and I would like to drill down into this column that we would like to change. Let's look at the unique values of this column. So these are the unique values. I'm going to remove, and with the underscore removed all, you decide which part you want to remove. So I will remove this part here because we don't need it. And I will remove this part here. Remember, there are spaces. And when I do that, instead of splitting it like this into 3 columns, when I remove, we will be left with only that middle part like we see here. It's going to be like we see here. That part is going to be left. But another thing I will do, I will not remove the spaces to show you how you can remove spaces when you run into such a situation when you are doing your data wrangling. So underscore str underscore remove underscore all says give me the string. So we give it the column and then the pattern that we would like to remove. The pattern here is, so I will take this part, I will leave that space before the total. And let me drop it there, but I need to use the quotation. So let me undo it. Control Z, that, and then I will use that vertical line to say or, then I'll take this here, that parenthesis number parenthesis, close parenthesis, like this. The problem with these parentheses are also special characters, or so let's say, let's run it and see what will happen. And so let's see what has happened. No, this is the one that we are working on. You see, it didn't remove, it removed the population comma, it left the space there before total, but it left the parentheses because I said earlier that these are a special character in R. So we have to tell R a different way of to remove those. So the way we will do it, I will add backslash like this. And now let's run it and see what has happened. Now we have removed those. So just a single backslash is also a special character in R, so it's not going to be removed. And so I escape this and tell R, okay, we won't remove that. And now it is the way we want it, but there are spaces. If we print these out, so let's say census, and maybe let me try to do pool H category. Let me try this. When we pull it out, no, it's not H category, sorry. I want the gender. So pull is another way, like pulling out a column, like we use a $sign. Need the gender, but here we need unique values. Sorry. We need unique values. When we do that, you see there is a space before, there's a space after, because we intentionally left that, because I want to show you how you can get rid of that. To get rid of that, that means we will have to come back again, repeat this, but this is not recommended because it's like double work. Then we will use underscore trim. We want to trim those spaces. And here it's saying inside, give me the string and show me which side. Here we will say both sides. And it is the gender column that we are working with. And let's say both. Now let's run it. Come back here. And to show, to see if that has worked, we will go back, or we will type again our data set. We'll pull out that column, gender. We'll look at the values. Now we have removed all those spaces. So this is how you would remove spaces. If it was on one side, on the right side, then you would say right. If it is on the left side, you would say left. But that's how you would remove it. Now I'm gonna comment it out because, like I said, it's a double work. All I have to do is add a space before there, and after that, and then add a space before here, and then run it. And this here should do it. That should have done it. Now, that's what I wanted to show you. So I'll come back here, rerun this. That's all we needed to do there. Now, what we need to do is just to group and summarize. So to group and summarize, I will just take that data. I'll take this data, census underscore 2. I will come down here. I will add my code chunk. And let's say census. Maybe we want to group by state, just state itself. If we want to pull out state totals, then we take our census 2, and then we add a pipe. Now, before dplyr 1.1.0, we use the group by function. And then here we want to group by state. And then we summarize. There are two variants of summarize. In the US, we use Z. It doesn't make any difference, but you base it on your we kind of English. Here, American English is a Z. And then we want the population column. We are summarizing this population column. So we will say, we can say population, or we can say total equals sum. So it's equal sum because we are summing the rows. Here, if there are NAs, then we need to include NA is equal true to remove NAs. And I think I'm going to go back to the filter function because there are 3 rows at the bottom with NAs, and there are 2 functions that I didn't show you. So I'll go back to show you those. Now let's run it. And the state, there are 10 states. So this is it. This is it here. So you see here. But I said earlier that is before dplyr 1.0.1.0. Now we can do the same thing. So I can take the same thing as state. I'll say state 2, census 2. Oh, why do I keep pressing the wrong key? And then instead of saying group by, we can use just summarized. This is what the POSIT or RStudio, the former RStudio company, is recommending to use going forward. You can still use group by, but they recommend using summarize. You put in the column that whatever you want to do whatever you want to do like you would normally do in the summarize function. But here we want it to be grouped by. So you say dot by, and we are grouping by state. Because there is only one column, I'm just going to type it in there. Now we grouped, we run this one, but I'm getting a warning that returning more or less than one row per group was duplicated with this one. Please use reframe in state. So let me see my state 2. Okay, so what it is doing, it is still retaining the columns because we had different columns based on different rows. So it's still retaining those rows, and that's why it is telling me this one. So what about reframe? Let's see what it's going to do. So reframe, we didn't get any, but we are still getting the same thing. Still doing it by gender. So let me go back. Oh, it's my mistake because I didn't summarize. I did not summarize the data. I just left population the way it was. That's why it is doing that. So I need to say sum. Sorry about that. And then run it. Yeah, now it's good. Okay, so now this is good. So this is the new way of doing this summarization thing here. This one here. Now the thing I didn't show you here, after you summarize, you dropped the grouping variable. So you say group groups is equal, and then you drop. There are other options, but I just say group dropped to drop that grouping. That way you will be able to do other operations on the data set or outputs later on. So this is how you do the grouping by. Now let me do another grouping by to do more than one column, to group by more than one column. So here we will say we need a state by gender and by age. I'll just say age instead of saying age category because that would be too long. I'll come down census 2, and then we pipe it into summarize. We need total for sum of the population column. We are grouping by. Here I use the C function. It's a state. Gender. Some age category. Yep. Because each age category, now we have 5 age categories, and there are two column, there is male and female. So 5 multiplied by 2 is 20. 20 multiplied by 10 supposed to be 200. No, it's 5 multiplied by 2 is 10. 10 multiplied by 10, 100. Yes, that's correct. So this is how you do summarization after the release of dplyr 1.0.0. I will go back up to the filter function to remove, or I'll go up all the way to show you how you checked. There are important steps that I skipped. So the first step is we want to inspect the first few rows to make sure, like to look at the nature of our data. Few rows. And we can use the hit function. We can use the hit function like this and say row. And this is going to give us 6 rows, but I use the dplyr slice underscore hit. By default, it just gives us only 1 row, so you have to specify the number of rows you want by setting n equal something. Looking at these, the column names are long, so looking at these, that's good. And the bottom part, it's the same thing. And inspect. Plus 5 rows. So we can use the tail function from base R. And it's showing us this. So you see there's one NA. The other one is the source and the download URL. Those are not important to us. But when you keep going, you see there are 3 NAs, rows with missing values. So this is why it is important to perform these steps before you embark on your data wrangling. I like using the dplyr version of L. We can take the raw data and pipe it into the function. So raw, pipe it into slice underscore tail, then give it the number of rows we want. Okay, I had forgotten that. And then now, when we come back to the filter, we want also to remove those. So here we will say we don't need, so we'll say, we say is dot NA. We need to specify the column that we could just use the drop NA, which is not always the best thing to do, but for our data set, since we don't need those 3 rows, we can drop NAs. But since we know, like here going across, we know the variable name column here 3 NAs, population also had 3 NAs, so I can use the population column to drop those 3 NAs. So I'll come here and say, now with the new dplyr, not read underscore, or the vroom and read R. It used to be a number column that is number in it used to be inside the quotation, like the tick, the back ticks, but now they are putting X before it. If I do this, I'm going to get an error. And so I need to put this one in the backtick, I believe. Let's say, is that the reason? Object not found. Okay. Oh, because we have changed this one to population already. That's why. So let's say pop. If we run this, we run it like this. We are getting 0. We are not getting any rows. So let me go back up. We have already removed those. So let me, I will not add it there. I'll come before. Yeah, I'll come here. And I will add a filter here. I'll say is dot NA. And then let's say X to 2008. I'm getting an error again. Okay, so let's say, oh, that's my bad. And so there are these 3 rows, we pull them out, but that's not what we want. So let me remove some of this. That's not what we want. What we want is to negate it. So to negate it, we just say this. And that will give us what we want. Now there are 450 rows, and then we pipe it in here. That's it. So those are the 2 steps that I'd forgotten, and I wanted to add them so that you have a complete picture of what is the most important steps when you are doing data wrangling. There's one more step that I'm going to show you, which is usually common with when you have like the Excel data. So let me add another code chunk. So here, knowing South Sudan, I know we had 3 original regions before we had 10 states. So I will add a column for the former regions. And the reason I'm doing this is when I added, let's do it first before I say that. So let's say I'm going to just call it DF as a data frame. And then I'll take my raw data set and then I will pipe it into mutate. And I need to create a new column. So mutate, you can add a new column. I'll call it former region. And then I will do case underscore when. So the thing that I need to do, so let me clear all these and then come back here. I will use this region name column. So what I will do first is to convert that to lower cases because I will use the detect function. So let's say region name equals str lower and then region or name. When I do that, so let me comment this out. I need to run that first. Now df. So I have converted this, and the reason you do this is so that when I say, I'll just say detect Nile, detect Jonglei, detect Unity, and then put those as the greater Upper Nile. If I don't do lower cases, there might be conflict because or it's case sensitive. That's why we have to convert it. So always convert to lower cases. And then, so here inside the case when I'll say str detect in the region name column, I want to detect the pattern. I'll say Nile or Jonglei or Unity. Because these are unique names or words to only those states from former Greater Upper Nile. And I'll say, if you detect those, please call these Greater. I can use lower cases, Greater Upper Nile. So there are 3 former regions. But at the same time, I'm not going to do all of them. I will do just 2, and then everything else I will lump together. Because The next one is actually straightforward. So I will just detect Equatoria. So there are 3 states in Greater Equatoria. So I'll just say detect Equatoria. And then call it Greater Equatoria. Now I'll say whatever is left, all the leftovers, call that Greater bar. I always misspell it, but now let's run it and see what will happen. If we get it right, then it should come out right. It will be added at the end. Okay, it is added at the end. But in mutate, we can instruct it to add it where we want it. So I will go back here. That part is the part of case underscore 1. So here I'll say dot before, and I'll say before region or name. We want to add it before that column. Now you see it here. But that's not what I meant earlier. So I'll leave that, but let me see something. Okay, I'll leave it like that. I will just do a different example or tutorial in the future to show how you can fill values, column values downward. But basically, this is what I wanted to share with you all today. Brief introduction to data wrangling. These are the most important steps. If you understand these steps, you should have data wrangling in R should not be a problem anymore. So I will add the code link. This codes will be shared on GitHub under the R_tutorials repo. And please let us know, share the video, and let me know if you have any questions. Thank you. See you next weekend.